Loops issue the prompts, so it's the system.
If the model that wrote the code also grades its own work, there are people who use it to deeply understand. It's a shortage of people who can define what counts.
Ugh, another mediocre result?
Sherry, what's wrong?
My AI agent works technically, but it's just not good enough for real use. No matter how many times I rewrite the prompt, I can't get it to feel reliable.
That might not actually be a prompt problem.
Wait, what else could it be besides the prompt?
There's a concept going around right now called loop engineering. Claude Code's developer Boris Cherny and the creator of OpenClaw both started talking about it around the same time.
Around the same time? I guess everyone ends up thinking alike.
I don't think it's a coincidence. I think everyone was hitting the same wall. Then at the end of June, Andrew Ng covered it in his letter, and it really took off. That OpenClaw creator, Peter Steinberger's tweet about it, is getting huge traction.
So it must really be striking a nerve in the developer community.
Today let's dig into why loop engineering is getting so much attention. There's this guy named Boris Cherny. He leads development on Claude Code. He's been saying something interesting lately. I don't type prompts to Claude anymore.
Wait, he's the one leading development and he doesn't type prompts? What does that even mean?
Running loops issue the prompts to Claude. My job is to write the loops.
Loops issue the prompts, so it's the system giving the instructions, not a person.
Right? Hundreds of agents read his GitHub, Slack, Twitter, and decide what to build next.
Hundreds of agents just finding work on their own and running with it.
What's interesting is how his workflow evolved to get there. A year ago, he was just handwriting code with IDE autocomplete, like everyone else. Around November 2025, he started running 5 to 10 Claude sessions in parallel, and then he uninstalled his IDE, said he just wasn't using it anymore.
Uninstalling the IDE is a pretty bold call, though.
From there, it went even further. Now he doesn't even type prompts directly.
That's a lot of change in 1 year.
According to Work OS Recap, they hosted the event. Over 90% of the Claude Code team's code is now written by Claude Code itself.
So they're using their own tool to write their own code. That's completely self-contained.
Though he does say only about 20% of the ideas coming out of the loops are actually good at this point. But he expects that to improve a lot over the next few months. So, here's why you actually need a loop. Think about the normal flow when you're just typing prompts.
A human writes a prompt, the AI responds, then the human writes the next prompt, and it just repeats.
Right? It's a completely linear structure. With that structure, the human ends up being both the scheduler and the quality checker.
So basically, if Sharina goes off to get food, everything just stops.
Exactly. It stops while you're asleep. It stops while you're in a meeting. The human is the bottleneck.
But I thought agents were supposed to just run on their own.
They run, sure, but who decides what happens next? Still the human, right? A loop structure is different. Discover, execute, verify, log, decide what's next. It all cycles automatically.
Wait, even verification is automatic. Does that mean you don't need the human anymore?
Actually, it's the opposite. You're not replacing yourself with the agent. You're replacing yourself with the one who directs the agent.
So you go from being the worker to being the one who designs the system.
There's a great line from an article on the new Stack about it. From operating the lathe to designing the production line. There's one principle that matters most in loop design. Separate, the one who writes from the one who verifies.
Separate? Can't the same AI just do both?
If the model that wrote the code also grades its own work, it gets lenient. It's like grading your own homework.
A good enough problem.
Right, so you need a separate verification agent. It runs on different instructions to double-check the work.
Kind of like a third-party check?
Have you heard of Claude Code's /goal command?
I've heard the name, but never used it.
You set a verifiable completion condition, and it keeps working until that condition is met. And a smaller model, handles the completion check. This is basically maker/checker separation turned into a product.
So even with a custom agent, the key is defining that completion condition properly.
Exactly, whether you can write what counts as done in a verifiable form. That's where the design splits between working and not. Andrew Ng breaks this loop structure down into 3 nested layers. The innermost one is the agentic coding loop. It runs on a minute-by-minute cycle. You hand it a spec and eval data, and the agent iterates on its own until it's done.
Is that where the maker/checker separation we talked about earlier actually plays out?
Right. There's this story about NG building a typing practice app for his daughter. The agent worked for about an hour, with no human intervention. It kept checking its own output in the browser, over and over.
So it builds it, tests it itself, and you're fine leaving it alone for an hour.
Next up is the developer feedback loop. That one runs on an hourly cycle. It's the loop where the developer reviews the output and course corrects. Last year, the developer was basically the QA person, right? Checking behavior, hunting bugs.
Yeah, I figured that was just normal.
Now that agents can test themselves, the human role is shifting. You get to spend your time on higher-level decisions. Feature selection, UI judgment calls.
So it's moving from squashing bugs to deciding what to build.
The outermost one is the external feedback loop that runs on a daily cycle, showing it to friends, alpha testing, A/B tests, getting reactions from the outside world. The data from that updates the developer's vision, and it flows back into the spec.
So the 3 loops are nested, each running on its own timescale.
And NG said something interesting about this. He says the human edge isn't taste, it's context advantage.
Not taste, but an edge in context?
Basically, humans know things about the user's situation that AI doesn't. As long as that gap exists, human in the loop can't be automated away.
Yeah, the vibe on the ground. What are users actually struggling with? AI just can't see that.
So, this is about why it suddenly blew up in June 2026. The idea itself had been around for a while. It's just that the pieces weren't all there yet.
The pieces, what specifically was missing?
There are 6 elements Osmani laid out. First, automations, a system that finds tasks on a schedule and assigns them out. Claude Code has scheduled tasks and GitHub Actions, and Codex has equivalent features too.
Something like automatically checking the repo every morning.
Next is worktrees and subagents, isolation for parallel agents, and a system for dividing up roles. That maker/checker split I mentioned earlier. Subagents is what makes it possible.
So you can define the one who builds and the one who verifies as separate agents.
Right? Then there's plugins, which connects external tools and skills and memory. Skills are project-specific knowledge written down, like a skill, MD. Memory is the mechanism that keeps state across runs.
So it remembers where you left off yesterday and picks up from there today.
This year, all 6 of these landed in both Claude Code and Codex. Now anyone can build a loop. That's why it took off all at once.
So it's not just theory anymore. It's actually something you can put your hands on.
Let's take a look at some OSS projects that actually implement loop design.
So it's not just theory, there's stuff that actually runs.
First up, RTK. It's a CLI proxy that cuts token usage by 60 to 90%. It compresses output from things like LS or Git into something more agent-friendly.
Yeah, running a loop for a long time can rack up a scary token bill.
We're talking about Git push output, going from around 200 tokens down to around 10. It basically functions as the infrastructure that keeps the loop running.
If it's not economically sustainable, you can't keep the loop going in the first place.
Next is Rufflow. It puts forward the formula, agent equals model plus harness. The harness is designed to give the model tools, memory, a loop, and a sandbox.
So it's not the model alone, it's the model plus the surrounding setup that makes it an agent.
Right? And with the learning loop, it can learn patterns of what makes a task succeed. There's also an autopilot plugin that runs the agent in an autonomous loop. Last one is matpocock/skills, a collection of skills organized by failure mode. The README says something like, without feedback, the agent is flying blind.
Meaning it moves forward without actually knowing how the code behaves.
The /TDD skill sets up a loop where it writes a failing test first, then fixes it. /diagnosing bugs is a diagnostic loop that goes from reproducing the bug to a hypothesis, a fix, and then regression tests.
So none of these three are really about strengthening the model itself.
That's exactly the common thread. They're investing in building structure for verification and iteration around the model.
So there's a whole area here that polishing your prompts alone just can't reach. Okay, I get the OSS examples, but where do you even start when building this yourself?
For a minimal setup, there are really just 3 things to nail down. First, keep a log. What you tried, what passed, what's still open. You record all of it.
Without a log, you end up repeating the same failures over and over.
Second, write out your completion criteria. If you can write a verifiable condition you could hand to a /goal command, you've basically won.
So it's not it kind of worked? It's this specific condition was met.
Right? If the end condition is vague, the agent can't judge it either. Last, separate out the verifier role. Run it under a different instruction, or in some cases even use a different model.
So you're building in that maker/checker split from earlier, even at this minimal scale.
Combine these 3, and you get a log right arrow evaluate right arrow reach by flow. That's the smallest unit of a loop. Osmani, the guy who popularized this loop-based approach, actually spells out the pitfalls himself.
It's kind of rare for the person who came up with something to point out its own weaknesses.
First up is token cost. The more you loop, the more it burns through, and things can spiral. If you're token rich versus token poor, how you use this ends up looking completely different.
Yeah, an org with a big budget and a solo dev can run a wildly different number of iterations.
Next, if the loop runs unattended, mistakes happen unattended too.
It's great that it just keeps running on its own, but if it goes off the rails, you might not even notice.
Even if you build verification into the loop, a human still has to make the final call. There's also this idea called comprehension debt.
Debt of understanding.
The faster the loop runs, the faster code you didn't write yourself piles up. Before you know it, you might not actually understand most of your own code base.
So you think productivity went up, but what's left is a pile you can't maintain.
This is the part Osmani stresses the most. There are people who use it to deeply understand and move fast, and people who use it to avoid understanding altogether. The loop doesn't know the difference, but you do.
Same tool, but the mindset you bring to it can flip the outcome completely.
There's a LangChain survey of over 1,300 people. 57% already have agents running in production. Another 30% are close to deploying. Combined, that's nearly 90% with something actually working.
So, I can build an agent. Isn't special anymore?
Right? Anyone can build a working agent now. But in that same survey, the biggest barrier, 32% named it, was quality.
That's the thing Sharina mentioned earlier. It works, but you can't trust it.
The bottleneck isn't model performance. It's a shortage of people who can define what counts as good and what counts as done.
So the people who can write the completion criteria, they're the bottleneck now.
The ability to define a verifier, that's becoming the rare skill. Ng touches on this in his letter too. As agents get faster, engineers are starting to take on part of the PM role.
So the job of connecting vision to spec is landing on engineers now. I get why loop design matters, but does that mean writing prompts directly is outdated now?
Not at all. Writing prompts directly is still just as valid. Loop design just adds a new option alongside it.
So it's not either or, it's about knowing when to use which.
If you're asking what I'd try first, it's putting your task's completion condition into words. Whether you can write down what counts as done in a way that's actually verifiable.
And if you can't write it down, that means you're not even at the stage where a loop makes sense yet.
Right? And once you can put it into words, add one mechanism to verify it. You don't need to automate everything at once. Start small and build up the iterations.
So it starts with putting the completion condition into words.
I really love how Osmani closed it out. Build the loop, but do it as an engineer, not just someone pressing go.